At the U-Motion laboratory at Umeå University, Sweden, we investigate motion patterns in the short and the long term after anterior cruciate ligament injury. We also compare to age and sex matched healthy knee persons and to elite athletes. Our research shows reduced balance more than 20 years after unilateral ACL injury when compared to age and sex matched knee healthy controls. In fact, over half of the ACL injured persons in our long-term follow-up could not stand on their injured leg for 30 seconds. This was regardless of whether surgical reconstruction was included in their treatment or not. The lack of balance wasn't only isolated to the injured leg, but was also the case for their non-injured leg. During vertical hops, our three groups, consisting of ACL injured persons treated with either physiotherapy only or with additional surgery, as well as our knee healthy controls, differed from each other with regard to trunk, hip and knee kinematics. Both ACL groups showed lesser range of motion and inferior landing control compared to the control group. When performing side hops, both ACL groups differed from controls with regard to knee kinematics and performed fewer side hops during 30 seconds. ACL persons treated with surgery had larger external rotation of the injured knee. The physiotherapy group had less knee flexion and larger external rotation of the injured knee during landing compared to controls. Both ACL groups completed fewer hops with the injured leg compared to their non-injured leg. In fact, our research, and that by others, indicates that ACL injury does not only affect the musculoskeletal system and mechanical knee stability, but also damages sensory receptors in the ligament. This has impacts on the central nervous system, leading to reduced proprioceptive acuity and thereby impaired sensorimotor joint control. Such deficits, particularly of the contralateral non-injured leg, suggest altered central sensorimotor processes following ACL injury, probably contributing to the 30 to 40 times higher risk of re-injury compared to non-injured persons. In addition, we have developed a new functional test which targets proprioceptive ability of the knee. The test involves stepping over obstacles of various heights with downward vision occluded and is designed to be applied in clinics. Initial results show that when ACL injured legs step over the obstacles as the lagging leg, they have a significantly lower foot clearance compared to the non-dominant leg of controls. We are also developing new standardized tests to evaluate dynamic knee stability using motion capture. Here we have an example of a standardized side hop test. Compared to knee healthy controls, athletes have a shorter contact time during the rebound phase and greater hip and knee flexion angles during both landings, despite presenting similar dynamic knee stability. These results indicate a trade-off between dynamic knee stability and performance. Attention should therefore be directed to the design and evaluation of neuromuscular training programs, both for ACL injured persons during rehabilitation and for sports people to avoid injury in the first place. Further work to optimize evaluation of dynamic knee stability in relation to general motion patterns of both the upper and lower body is needed. Through new projects and collaborations, we hope our innovative methods help to further our knowledge so that we can better prevent and rehabilitate ACL injuries. A huge thank you to all those who have made our research possible by financing us, and thank you for taking the time to watch our video.